All right, so I kind of did a diagram. If you're stuck, you can see this. All right, what is known is that each side is a square. So that means everything is x, 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 and that's unknown. We don't know what the side length is yet, but we just know that everything is x. Now, if Sophie's Rubik's Cube has, each side is twice as long, well, then that's going to be 2x. All right, so let's first figure out step one. Let's figure out, we're breaking down the problem. Let's figure out what the side length is of Emma's cube. All right, so the formula for the surface area is equal to, well, how many squares do we have? There is 6. And so each face is going to be x squared. Aha, so then we know that that is 24 centimeters squared. Okay, so I'm going to divide now because I'm solving this equation that I created. And I get that x squared is going to be 4 centimeters squared. And then finally, I'm going to do the principal square root. And what is that? Well, when you are solving and you take the square root, you should always consider the positive and negative roots, right? Because -2 squared, the quantity -2 squared is still +4, so you have to consider that. Except when we're dealing with real things and side lengths, we don't have negative roots. So that's the principal root. It's just the positive one. So that means that x is equal to 2 centimeters. All right, so you see by solving that step of the problem, we now can bring this to this problem at hand. So we know now that Sophie's side length is going to be 4 centimeters. And that the surface area of that is going to be 6 times 4 centimeters. And then we're going to square that, right? Because there's 6 of those squares, and the area of each one is 4 squared. So that's going to be 16 times 6. So it's 36 and 60, so it's 96 centimeters squared. Right? Does it seem reasonable? It's up to you. I think it does seem somewhat reasonable.